Another consignment of wool arrives fresh from the farm. The bales are unloaded and sorted into lots. The lots of bales are then fed onto the sampling machine. Each bale is cut by the hot knife, and then a grab sample is extracted by the hydraulic jaws. The excess is pushed back into the bale. Next, the bale is weighed and recorded in our database. The bale is tilted in the core machine and then compressed. The core tubes are driven into the bale and the core sample material is expelled by compressed air into the sample bag. After the core tubes are extracted, the bale is ejected from the core machine to join the others in the lot. The core sample is used for laboratory testing for fibre diameter, colour, yield and vegetable matter content. The grab sample is subsampled for staple length and strength testing, and the remainder goes into the display floor for pre-sale appraisal by buyers. The grab sample material is distributed thinly and evenly over the conveyor belt of the mechanical tuft sampler and conveyed to the tufters. These three sets of pliers are designed to minimise bias by picking out individual staples from the grab sample. The tufts are vacuumed away and laid on a mesh ribbon for transport to the testing laboratory. At the laboratory, the mesh ribbons are unrolled to release the tufts, and 4 operators prepare individual staples from each tuft of even thickness. The staples are placed on trays with identification attached. The samples are then held in a controlled atmosphere for a minimum of 4 hours to stabilise their shape before being measured. Each staple is fed into the Atlas machine, an automatic machine for measuring staple length and strength. Length is measured by light beam interruption as the staple passes through the LED array. To measure strength, the staple is clamped between 2 sets of jaws, 10 mm in from each end. The jaws extend each staple to breaking point, and the force required to break the staple is measured in newtons per kilotex. The broken staples are weighed to determine their linear density. The relative weights of the broken tip and base of the staples enable the point of break to be recorded as being in the bottom third, the middle or the top third. All of the measurements for the staple are logged in the NZWTA database and checked that the results from each instrument are within range and analysed for consistency. The results are published in our buyer's catalogue. The average length of staples in the lot are measured in millimetres. The coefficient of variation, CV staple length, is also published. The lower this number, the more uniform the staple length is, and a higher number indicates a more mixed staple length. The staple strength is expressed in newtons per kilotex, newtons being a measure of force, and kilotex is weight per unit length. Because the weight and length of the staples varies, they are standardised by newtons per kilotex. The point of break defines which third of the fibre length the break is occurring, tip, mid or butt. Mid-fibre breaks affect processing performance the most.